Step 3 of drawing or graphing a quadratic function. So far we have done steps 1 and 2. We found the vertex and we found the y-intercept. So if you don't know how to do steps 1 and 2, you need to go back and watch that video. But step 3, to find the x-intercepts, hopefully you know what an x-intercept is, and hopefully you can guess the y-intercept crosses the y-axis, and the x-intercepts are going to cross the x-axis. And that's where we're going to draw, and that's where it's going to hit the x-axis. To find these, you have to factor, my favorite F word, factor the quadratic. Factoring is going to be a very important thing in Algebra 2 for the rest of the semester. So if you don't know how to factor, this is a skill you need to be able to master, at least the steps to it, because there's a different way to factor different quadratics and different functions. And so we are going to practice factoring from here on out. We're going to hit it harder in Module 3. But factoring is still necessary to know for this module as well, because we need to be able to place the x-intercepts in order to draw the function, the graph of it. So, to find it, you factor the quadratic. I think Miss Coleman's favorite word was factor. The F word was factor. I think she said that first. Anyways, set the factors equal to 0 and solve. So you factor first and set the factors that you get equal to 0 and solve. Your solutions represent the x-intercepts, or intercepts, or where the W, the graph, crosses the x-axis. Very important to know. You need to know that for the rest of your math career. So key features of this, we're still working with the same parabola. And this factoring, the first step of pulling out a GCF, we're not necessarily going to practice as hard in this module. We're going to work and practice harder on that in Module 3. But just for an example, stay with me as I pull out a GCF, a greatest common factor between the three numbers 2, 4, and 2. But then when I get to this part, that's the part of factoring you're going to need to know for today's practice and tomorrow's practice. So I'm going to do 2 strategies. You can pick from either one to work with. It does not matter. I'll do the first strategy on the left here. With this function, I pull out a GCF of the greatest common factor of 2, 4, and 2 is 2. 2 goes into 2 once, and 2 goes into 4 twice. It's not 4, because 4 doesn't go into 2, and it has to go into all 3 of them. So if I do that, I'm going to divide out 2 from each piece. The A term, the B term, and the C term. So if I do that side math really quick, 2x squared divided by 2. 2 divided by 2 becomes 1, so I'm just left with an x squared for my first term. Next term, 4x divided by 2. 4 divided by 2 is 2, so I am left with a 2x. And 2 divided by 2 is 1, so I will do plus 1 to finish it off. Now, you'll hear me say this a lot when factoring, especially when you're pulling out or dividing out a GCF, a greatest common factor. If you don't do side math over here and you come across the wrong answer at the end, I'm going to always make you do side math, piece by piece, dividing by the greatest common factor. And once you do that, then I will help you. If I don't see side math, I can't offer any help unless you try to do the work on your own first. So, with this strategy, now I've kind of run out of room, but you're going to only factor now this, x squared plus 2x plus 1, the quadratic trinomial. Now, these are the types where the leading coefficient right here is technically a 1 now. You're only going to be working with factoring with leading coefficients of 1 to draw their graphs for the purposes of Module 2. We're going to factor harder next module. So what this little diagram means is that there's a couple different ways to talk about this. It's you multiply to the outside and add to the inside, or you multiply to the C term that adds to the B term. So you need to find factors of whatever the C term is, which in this case, again, it's important to identify A, B, and C. The C term is 1. I don't really have room to write that, but again, the last term, this is the C term. So whatever the C term is, I'm going to put up here. And then I'm going to draw, they already drew it for you, but I'm going to draw little arrows like this. And then I need numbers that add or multiply to 1. Multiply to 1, so multiply to the outside. Multiply to 1 that add up to the middle, which the middle is 2. So it needs to equal 2. So they multiply to 1. The only ones that won't work in this case, it's really easy. 1 times 1. 1. So 1 times 1 equals 1. 1 times 1 equals 1. 1 plus 1 equals 2. So my factor form then, after I find the factors, and again, as you're doing this, the hardest part about factoring is honestly finding the factors that multiply to the C term and add up to the B term. But this one was really easy. I'll just rewrite, instead of standard form up here, I'm going to write it in what's called factored form. So each one gets an x, and since both of these ones are positive, it's going to be x plus 1 in parentheses and x plus 1 in parentheses. They put them in parentheses for you, but you always, 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 always have to put your factors in parentheses. So please make note, and we'll talk about this more next module as well. This form down here technically is factored form. This form up here is standard form. They're the same thing, just different forms. It's the same quadratic function. Hopefully, technically factoring is called division, so hopefully if you were to multiply x plus 1 and x plus 1 back, you can guess that you would get the same beginning function that we started with. That's the first strategy. The second strategy of factoring I like to use is called a MAC-AB t-chart. So a MAC-AB t-chart works the same way. I'm going to draw what looks to be just a t-chart, and the MAC term goes here. MAC stands for you multiply the A term, which is 1. I'm going to use a different color to see this. You multiply the A term, which is 1, and the C term, which in this case is also 1. This works every time, because there will be times when the leading coefficient is greater than 1, and the factoring looks a little bit different, but the first step is always the same. You multiply the A term and the C term together. And then this is the AB part, is that all that stands for is that the two factors have to add A up to B, the B term. So I put the B term here. So I need factors of 1 that add up to 2. And in this case, we already found them out, 1 and 1. 1 times 1 is 1, 1 plus 1 is 2. We have found them. So from here, it's not already written for you, but you need to be able to put them in parentheses every time. And those are my two factors. Once you find the factors, and again, for factoring, if this number wasn't 1 up here and it was a little harder, just start with 1 and whatever the number is. So let's say it's a 5. Start with 1 and 5. If those numbers, 1 plus 5 is 6, but the B term isn't 6, then go down to the next number, 2 and its partner, to get to the AC term. And we'll talk about that more as we begin to factor more, but that is a smart process to consider. So I have my factors. I set both my factors equal to 0. And in this case, they're the same thing. X plus 1 equals 0. And I guess, let me rewrite that. When you want just the factors, if your final answer is just factors, then it's fine to you need to put them in parentheses. But if you're trying to solve, you don't have to put them in parentheses as well anymore. So x plus 1 equals 0, x plus 1 equals 0. In this case, you minus 1, minus 1, minus 1, minus 1. So x equals negative 1, and x equals negative 1. That is how you find the x-intercepts of a quadratic function. And please don't get frustrated with factoring. It is going to be frustrating at first because at times you're not going to be able to find terms or numbers that add up or multiply to the C term and add to the B term, but it's just a kind of a guess and check process, and we'll talk about strategies that you can use to make it a little easier on yourself. if you can't mentally think about it quickly.